day. My name is John Mark M. Rosales from IS4202 and I will be reporting about sedimentation and flotation processes. So without further ado, let's get started. Sedimentation and flotation. Sedimentation and flotation are purification processes whereby the water to be treated is kept in a tank for a considerable period of time. Purification is the process of removing undesirable chemicals, biological contaminants, suspended solids, and gases from the water. The goal is to produce water fit for specific purposes. One of the most specific purposes is for drinking purposes. Water is treated so that the water to be drunk by the people are safe and are free from contaminants. Seen here is the figure showing the difference of flotation and sedimentation. We can see on the left side of the figure that flotation is going up and that sedimentation is going down. Flotation is caused by buoyancy, while sedimentation is caused by the gravity. Let's start with sedimentation. In sedimentation, gravity can be used to separate a solid phase off from a fluid. When solid particles are suspended in a fluid, gravity causes them to sink. For this to happen, the density of the solid must be greater than that of the fluid. I will be showing you a video of how sedimentation really works.
And here we have a rectangular sedimentation basin with its influent zone. So the first zone of a rectangular sedimentation basin is the influent zone, and this is where water enters the tank. As the water moves through the tank, it enters the settling zone, and this is where the settling takes place of the particles that will settle out. And at the end of the basin is the effluent zone, and this is where the water leaves the basin. And on the bottom, we have the sludge zone. The sludge zone is where the settled solids collect. So these are the four main zones of a conventional sedimentation basin, whether it's rectangular or circular. The influent zone, the settling zone, the effluent zone, and the sludge zone. Here we can see that there's the sludge collectors moving the sludge to the influent end of this rectangular clarifier for processing. Here we have pictured a round clarifier or a circular clarifier. The water comes in the influent into the center stilling well. This is the influent zone. The water then leaves the stilling well and moves outward through the settling zone. Settleable particles settle out, they enter the sludge zone at the bottom of the clarifier, and the outer edges make up the effluent zone. On a circular clarifier, the effluent rear goes around the entire circumference of the clarifier, and that is the effluent zone.
Water and wastewater engineering. Many settling tanks operate by natural forces alone, by gravitation, and by natural aggregation of suspended particles. This process is called plane sedimentation. There are two subdivisions of plane sedimentation. The first one is the discrete settling, and the other one is the flocculent settling. Discrete settling occurs when the amount of natural aggregation is negligible, as for instance is the case with sand grains. During the whole settling period, the suspended particles maintain their identity and consequently move down at a constant rate, as we can see later in figure 1.3 at the left. With flocculent settling, on the other hand, particles overtaking one another will coalesce and will henceforth go down at the higher rate of the aggregate, as we will see later in figure 1.3 at the right. Flocculant settling is predominant with organic impurities as found in municipal sewage and many industrial waste. Seen on this figure 1.3, the settling of discrete and the flocculant particles. On the left part is the discrete settling. As I've said earlier, the particles will maintain their identity and move down at a constant rate. On the other hand, on the right part of the figure is the flocculant settling. The particles will overtake one another and coalesce. By coalesce, we mean that they will come together and have one mass. Hence, they would go down at a higher rate because of their combined mass. And now, we will proceed with flotation. Why do you think is flotation used? Well, suspended solids with a density close to or less than that of water can't be removed by sedimentation. Such solids would sediment only very slowly or would remain suspended. The aim of flotation is to increase the buoyancy of the solids. Archimedes' principle of buoyancy states that an object fully or partially submerged in water would be buoyed up by a force equal to its weight. Going back to flotation, this is done by forming small gas bubbles that attach to the solids. This makes them rise to the surface of the water where they can be skimmed off. It is required that the solids should be hydrophobic. That means that they are more wettable with air than water. The separated solids are termed float. The key factor influencing flotation is the size of the gas bubbles. I will be showing you a video about dissolved air flotation, a kind of flotation.
Dissolved air flotation, or DAF, is a water treatment process that removes suspended solids from water using air. This separation is achieved by dissolving air into water under pressure and then releasing the air at atmospheric pressure in a flotation tank. The released air forms tiny bubbles which adhere to the suspended solids in the water, causing the solids to float to the surface, where they can be removed by a skimming mechanism. Chemicals can be added to the feed water to improve solids removal. The DAF process can be used to clarify fresh water, processed water, and wastewater so that it is suitable for use or discharge. In some cases, the solids are collected for reuse. Common applications include clarification of municipal water and wastewater and processed water in paper-making operations.
Dissolved air flotation is the kind of flotation that uses the fact that the solubility of air in the water increases as the pressure rises at constant temperature. Some of the treated water is saturated with air under pressure or recycled water. The recycled water is then injected into the flotation tank through a special valve that causes an instantaneous reduction in pressure with the use of relief valve. The sudden relief to atmospheric pressure causes the dissolved air to precipitate as a cloud of small bubbles.
Good morning everyone, I'm here to present. I am Jimmy Steve and I'm here to present the different types of flotation. First is fill and drop. In this process, as you can see in the illustration, that there are tanks that is to be filled and this can be filled. This part is the sludge source where the impurities or the sludge were settled. It is at the bottom because it's more dense than water. Then the sludge will remove the sludge under the tank where it is settled. Then clear water will be filled. Next is continuous filling tank. This is the type of filling tank that running water is settled, but not running water. Maximum velocity will be 0.3 meters per second, so that the impurities will settle at the bottom and the is circular tank. Circular tank is almost the same with vertical flow. They both have the same purpose. They're which they or the inlet is in the middle, then the sludge zone is at the bottom. But the circular tank is used in larger water treatment, and vertical flow is for small spaces. So for limited spaces, because this is too wide too wide to use. It needs larger space than this. It needs only downward and space under, or you can get it under the ground. Then it's settling tank. It's almost the same with cylindro, but in this case we have more bar sheet or sheet plate that where the sludge is to be settled, but they also is at the bottom. You can also settle the sludges or the in water. But this time it's more under more layers where sludges can be settled, and the next is filtered plate settling tanks. Filtered plate settling tanks is like the previous one. It has a bar screen that it will only point up, then it will be cleaned with jet water. Yes, jet water. It has more sludging zone, or the sludges will be settled here in the bar screen, and others are settled down here, then it will be collected by the sludge, and that will be outside.
Hello, my name is Mark Jester Delangin. My topic is all about application of sedimentation and flotation in water and wastewater treatment. First is public and industrial water supply. Filtration is the main treatment to which water is subjected. Here in the diagram, the mixture is agitated quickly and thoroughly in a process called flash mixing. Flocculation is a process to which the destabilized particles are bound together by hydrogen bonding or van der Waals forces to form larger particles flux, during which further particulate removal takes place by entrapment. Here in the diagram, it shows that there is a groundwater which has high content of dissolved iron. By aeration, iron will be oxidized and converted into insoluble ferric hydroxide, which may subsequently be removed for large part by settling or plain sedimentation. Aeration brings water and air in close contact in order to remove dissolved gases and oxidizes dissolved metals such as iron, hydrogen sulfide, and volatile organic chemicals. Softening is a process of removing the dissolved calcium in the magnesium salts that causes hardness in water. In water softening, it uses lime soda, which turn into insoluble calcium carbonate and magnesium hydroxide. CO2 is used for pH adjustment and for the neutralization and precipitation of the calcium hydroxide in the primary basin effluent in cases where high magnesium waters are softened by application of excess lime following by recarbonation. Next is the domestic and industrial wastewater. Clarifiers are settling tanks built with mechanical means for continuous removal of solids being deposited by sedimentation. Sludge are thick, soft, wet mud or similar viscous mixture of liquid and solid components, especially the product of an industrial or refining process. Digester is a container in which substances are treated with heat enzymes or solvent in order to promote decomposition or extract essential component. Here in the diagram shows that trickling filter. A trickling filter is a non-submerged fixed bed reactor consisting a highly permeable packing media in which aerobic condition is maintained via diffusion, forced aeration, natural convection, or splashing. In treating domestic industrial wastewater, sedimentation is of paramount importance. Next is the activated sludge process is a biological wastewater treatment operation. This means that treatment occurs through many different microorganisms using pollutants as food source. Grid chambers are long, narrow tanks that are designed to slow down the flow so the solids such as sand, coffee grounds, and eggshells will settle out of the water. Grid causes excessive wear and tear on the pump and other plant equipment.